Welcome to Honors Geometry, Lesson 2.7, Theorems, Linear Pairs, and Vertical Angles, where we continue where we left off, messing around with some statements, postulates, and theorems, and then even proving a couple of those. So let's get at it right now. Okay? What is a postulate again? This is review. And yes, I know. I'm going to ask you what the answer is, and I'm going to say, great, that's right, even though you got the wrong answer. A postulate is a statement accepted as true without proof. A theorem is, from yesterday's notes, as well as today, a statement proved true. So let's go right at it. Let's look at our first theorem and go ahead and prove it. Here we go. The right angle theorem. The right angle theorem states all right angles are congruent. So we'll get the two-column proof set up, and when you're done, you go ahead and start it back up, and we'll get going again. Be right back. Alright, let's go ahead and start with statement number 1. Hey, I don't even need this. I can just get rid of that, can't I? Because there's not going to be any secrets this time. Okay. What are you going to start with for a statement? Oh yeah, you guessed it. Only thing you can. Angle A and angle B are right angles. Why? It's given. Hey, what do you know about right angles? Seriously, what do you know about right angles? Yeah, they have a measure of 90. So, statement number 2, the measure of angle A equals 90, and the measure of angle B equals 90. Why? It's always why. It's because that's the definition of right angles. Angles that measure 90 degrees. Alright. Okay. Look at this statement right here. Can you make a new statement from that? I think you can. You got two things that equal 90. Since they both equal 90, they have to equal each other. Wow, I forgot to write angle A there, didn't I? The measure of angle A is 90. Sorry about that. Measure of angle A equals the measure of angle B. What allows me to put in equals for equals? Substitution. And there you go. Our last statement. What do you know about angles if they have the same measure? That's right. If they have the same measure, they have to be congruent to each other, because that's the definition of congruent angles. And just like that, it doesn't matter what angles A and B are, we've proven it's true for all cases. Hey, we've just proven the right angle theorem that all right angles are congruent. Okay, let's look at a postulate and a theorem that we've actually already talked about, but we're going to actually get in and dig in a little bit more formally. The linear pair postulate. If two angles form a linear pair, then they are supplementary. Okay? Angle 2, angle 1, they form a linear pair. They're supplementary. I'm not going to spend a lot of time on this postulate. It just makes sense. Other than the fact, if you don't want to write it out, you can go ahead and write LPP. However, I don't want you saying LPP. Instead, I want you to say linear pair postulate. This is just to keep you from having to write too much. So you can abbreviate it LPP when you're writing it down. But even when you write it down and I ask you to read it, you should be saying linear pair postulate. And then because of the linear pair postulate, the following theorem kind of like falls into our lap. The vertical angle theorem says vertical angles are congruent. And yes, I know we've already talked about it and we've already used it. Yeah, even on the chapter 1 test, I realize that. But now we're actually saying it formally. We've never actually come out and said, hey, this is a theorem. And the proof would go something like this. I'm not going to draw all the pictures, but I'll just go through the steps really quick with you. Angle 1 and angle 2 form a linear pair, right? Sure. Angle 2 and angle 3 form a linear pair. And the reason is, for both of those, that's the definition of a linear pair. Their non-common sides form a straight line. Okay? Then we can say angle 1 and angle 2 are supplementary. And we can say angle 2 and angle 3 are, yes, supplementary. What allows us to say that if we know they're a linear pair that they're supplementary, hey, we just talked about it at the last screen, the linear pair postulate. Okay. The measure of angle 1 plus the measure of angle 2 equals 180. And also the measure of angle 2 plus the measure of angle 3 equals 180. Why? Why are those two true statements? From this statement right here, you say they're supplementary. Here you're saying that their measures add up to 180. That's the definition of supplementary angles. Hey, you guys. Hey. You got two things that equal 180. That means that those two statements must equal each other because of substitution. And some instructors and some books will also say, hey, that's a transitive property as well. And yeah, I guess if you want to switch the order of the way things are, you could say it's a transitive property. With equality, I much rather say substitution is why we can do that. Since those two expressions are both equal to 180, they got to be equal to each other. Hey, do you see the measure of angle 2 on both sides? I do. Why don't we go ahead and subtract the measure of angle 2 from both sides? The measure of angle 1 equals the measure of angle 2. What allows us to take away the same thing from both sides? Subtraction, property of equality. And that's why I like to all cap substitution, so you don't get it ever confused with subtraction property of equality. And then the last line, angle 1 is congruent to angle 2 because their measures are equal and the angles are congruent. That would be definition of congruent angles. And that is how you would, if you wanted to set up a two-column proof, prove the theorem that all vertical angles are congruent to each other. Sweet. So we actually learned our first theorem in geometry. I know you learned the Pythagorean theorem last year, and we'll talk about that in chapter 7. But for right now, I think that's all, folks, for Honors Geometry Lesson 2.7. Thank you. Have a good weekend. Bye-bye.